And let's get stuck right into building some code to build our own meta network. So I'm just going to go into our script editor. And what I'm going to do is I'm just going to copy some code across. So what I have here is nothing to do with Hive. This, in fact, is everything to do with the MetaSystem. What we want to do is look at the underlying functionality, how this gets created and how to manage it. Because once you understand this, you understand how a build system works when it comes to the MetaSystem. And it's pretty straightforward. So the first thing is I'm going to import our MetaSystem. You can see it's got nothing to do with Hive in this case. I'm also going to import our internal API, which is called the Zoo API, which is a wrapper around the My API. This allows working with the node graphs and attributes a lot easier. The first thing I'm going to do is create a blend matrix. Now, it doesn't matter what node I create, it could be a transform or so on, but I'm just going to create a blend matrix. All right, so we have my test. Don't worry about that, that's just Maya screaming. Now, what we want to do is basically store the blend matrix in some way so I can later retrieve it. That way I don't have to care about its name. I don't have to look up against the scene for my test one. I can, because that's the node name here. I can look up against the scene for a specific node, not by its name, by some metadata, then access my test through that, because this is how Hive works. So what I'm going to do is just create, right? So we just created a meta node. This is the base foundation of what Hive uses, but some of our other tools use it as well. It creates 4 main attributes. There's the Maya class, the M version, so you can deal with versioning if you need to, and you've got the meta children and meta parent. Now, the next thing is I want to connect this my awesome node to my test, or the blend matrix, so I can later retrieve it. So in this case, I'm going to go down the bottom here. I'm just going to go n.connect to. You start to see that we just created the my blend matrix attribute, which corresponds to that. And it connected to this node as the message attribute. One of the most important things with this system that differs from other systems like this is that we don't create attributes on the custom these nodes. We don't do that. The reason why is something that I've learned over time, is that as a pipeline TT, I absolutely hate it when there's all these custom nodes on arbitrary nodes, when I have to do things like write export tools, or I have to write animation tools, and one of the first things I have to do is trash all these extra attributes because it's interfering with the scene itself. Like, for example, Arnold is a classic case where it adds all these extra attributes which can interfere with animation. This is the same for if you're adding attributes to a joint, for example, that needs to be exported. We really don't want to export those attributes out. So this is a better way of doing it, where it just creates all the attributes on your meta node and creates a connection to that node. This makes a lot of other things more efficient as well. From here, what we can do is now we want to get access to my test. Well, let's write some extra code. So there's a couple ways of doing this. We already have access to our awesome node, but how do you get access to this later? Well, there's honestly a couple ways of doing this. So let's have a look at that. The first way of doing this is going and saying base.alliterate meta nodes. And if we just print this out, meta, because I've changed the import name. Now if we have a look at this, we just pulled out every node in the scene, which includes all of Hive. You can see there's quite a few. So down the bottom here, we have my awesome node. This literally returned us based on the node type and whether it's got the M class flag. It doesn't tell us, it doesn't retrieve my awesome node by the actual base class here. In this case, I would want to call this my awesome node as the M class, but we'd have to create a custom plugin for this. This is something we'll do in another video, so you can learn how Hive deals with persistence between zoo scenes and everything else. But this is a really good start, because at this point, we can also filter by another kind of solution, which is the class type. And this can be done by find meta nodes by class type. And in this case, the class type is this attribute name, or the attribute value. So class, metabase. So we would just return my awesome node. But if we also create another node, and we do that again, we just return both of them. But you can also see we just filtered out all the Hive stuff because Hive is a custom M class type. But this is really useful, even as a starting point. Now we could access the actual blend matrix here, pretty straightforward. So if we go and say n.my blend matrix, you return the actual plug, or what's typically called the plugin line, not the attribute. The attribute and the plug are two separate things, but they can mean the same thing depending on the context you're working in. You can just think of it as the attribute if you wish. Now, this doesn't return you the source node of the blend matrix. So how do you retrieve that? Well, you just go source node. And this returns you to my test. You can also go say value, and this will return the same thing. Now, if this is a bool or a float and so on, which we'll have a look at in a moment, it will do the same thing, but return you the value. So source node is when you want to retrieve the connection, whereas value returns you the kind of value of the node, not the attribute itself. Even if when it's not connected, it will do that. When it's connected, it won't return you the node, it will return you the value. So what if we want to create a disconnection? So we want to disconnect the blend matrix from the meta node. Well, the great thing is that's actually quite fast because we don't have to worry too much. We don't want to delete the attribute, we just want to disconnect it. So in this case, we just go from the blend message attribute and disconnect it from the blend matrix. So you can see that connection is now gone. If we do this again, but now we want to create a connection between these two meta nodes, and this is how Hive actually works. What we can do is just go add meta node on the second node, and now you have this connection. So now what we can do is go and say alliterate the children, which will return us no nodes because it only returns you the connections. So for example, if I create a connection there by hand and do it again, it will return these nodes as a list or a generator function. This is really useful because if I disconnect this attribute, I can also manually connect it up again without any extra work, and everything continues to work. You'll start to see the more power of this when it comes to things like creating tagging. Since Hive is all like working off this, it means that code works dynamically. So if you disconnect something, it won't exist anymore. If you create a new value, it won't exist. But let's have a look at something a little bit more advanced, and that is compound attributes and arrays, because that's what Hive uses if we have a look at that. So for example, if we have a look at something a little bit more complex, let's say the Hive layer here, you have the H inputs, you have all the inputs for nodes, and you have the source inputs and so on. It gets a little bit more complex depending on what you're dealing with. For some, this might be too complex. Well, for other reasons, this is actually a really good way of working. You can see in the channel box, the attribute editor, all the metadata for that as well. Unfortunately, Maya doesn't allow you to visualize nested compounds and so on, which is a bit of a limitation that I don't like. Now, let's actually create this because we want to mimic some of the Hive behavior so we better understand it. So in code here, I've got a bit of snippet of code. The first one I'm going to do is create a bool. So my adder is just a checkbox, essentially. Now we can do that by specifying the type to be a KMFN numeric boolean. Now this is pretty important because if we actually have a look at this particular location, you'll start to see what types we actually support in ZooTools. So if I just open up PyCharm here, and if I go and have a squiz down to zoo, libs, Maya, API types, you'll start to see every attribute that we have here. This is every attribute that we support. The only exception might be, I think, the float array, because Maya doesn't technically support that by the Python API, but we support essentially 36 types. And the underlying creation of the attributes will handle the rest for you. This means you don't pass in the attribute type as a name for a string, you pass it in as a constant value, so one of these. You don't pass in 1 or 2, you pass in the actual constant value because it's much easier and means that you'll survive against any changes that we make. This is why we created a bool like this. Then we set the default value, the key, it's keyable, and the actual value currently is false. Now we want to go more complex type, being a compound. So let's do that again. And you start to see that we have some interesting behavior. We have created a compound, but if you have a look at some 2 important flags, well, 1 important flag, but it's specified twice, is the isArray. The isArray makes the compound an array compound, which means I can essentially store a bunch of attribute data for 1 particular attribute value or compound. So if I have a look at this into the adder map, which is all the child attributes, which can be nested, by the way, so you can go as deeply nested as you possibly can, because it supports what Maya supports. And if you move across here, you say that's also an array. So we have a compound array of arrays. So can be a little bit confusing in this kind of example, but this is the same thing as if we look at the blend matrix. It's actually doing this. Very similar. You now have the power of creating more complex attribute types right inside of the MetaSystem as well as Zapier itself, which is the underlying API. This is actually all you really need to know in terms of how Hive works in terms of its brain. You can store any kind of metadata on here, from complex data types, which in this case you serialize to a string. You can do something a little bit more interesting, which is you can actually serialize an attribute. For example, this is how Hive works. So if we go to any individual attribute, like I've done, I went to my compound 2, which is this particular attribute here, and I said serialize. Now, because that's a complex attribute, it's going to serialize a little bit differently. You can say it's specified the type and all the individual children and the defaults and so on. If I wanted to serialize my type, my adder instead, I can do the same thing and change this to my adder. Now we'll get into more of this later when we look into serialization in Hive, because it is, at the end of the day, quite complex. And how this works, it's a fair bit of code. But underneath the hood, it's just essentially one line off you. Now, understanding this kind of understands how Hive works. But let's have a quick look at that so you can kind of get a general understanding of how this maps to the code. I just grab a new tab, and the first thing I do is I'm going to search for my rig. This, again, is the MetaSystem. So I just initialize the rig, and I go to rig.meta. We see that we've created, we get access to the rig, right? So if we go back to our tab here, it's this guy here. Now I can specifically get access to a particular attribute, for example, is Hive. Oops, I need to do that on meta mode. Now we have access to the block. Now, we don't want you to access these attributes independently unless you really need to hack around and play around with these kind of things. We actually have wrappers, and that's what these classes are for, which are plugins, which we'll get into another video on how to build it yourself. This makes it really handy for building your own nodes that store metadata for doing things like inside your build scripts, where you can kind of attach your own rigs and have a meta system sitting on top of that, which basically connects up to your controls, your joins, and so on. So when you write tools, you have a more consistent way of working. So you don't have to worry about naming so much. In fact, part of this is how the spine works in Hive, where we store extra attributes on metadata. This leads to something else. If we have a look at this and go, I want to get access to the spine, what does this do? What does it do underneath the hood? Now, other than potentially using our cache that we have in memory, if it's inside the cache, it'll just return it for you. But if it's not, it's going looking for it. But it already has access to the rig meta node, which is this guy here. But now it needs to go search. Well, the meta framework behind this has all the behavior you need. So when you do something like for meta node, in rig.tolerate meta children, and we just print this guy out, you'll start to see that it returns to, oops, I keep doing that. You'll start to see it returns to every single meta node, which also means you can do some crazy things with that. But this is essentially what r.spline_m is doing, or if you want to do it a better way, which is what I do, which is do it by a string name, which is the equivalent, but actually underneath the hood it's a little bit faster computationally. You're getting access to the spline. But how does this work logically from the graph? Well, it's using a transversing kind of technique. So it's recursively going down your meta network. It's starting here at this node, gets access to the component layer. It's explicitly looking that up because I know for a fact that it's going to do that. It's then going and saying, hey, get all the children called M from M meta children and start walking the graph. So if I graph all this, it goes to this node here, which is the God node M, and then goes to the M meta children section here and loops through this entire array. Now, these arrays are empty because they're probably connected to the actual layers. It's then going to see this spline M meta. It's then going to check to see what the actual component type is. So in this case, it's the Hive component. It's then going to check to see what the Hive ID is and the Hive side. It's then going to combine that together to check against what you've passed in. So it's going to check against these two arguments to make sure it matches. When it matches, it's going to grab this and it's then going to initialize your component. Now, I want to stress a bit of a difference here between the meta classes that you work with, so for meta nodes. So this r.meta is essentially a high meta node, and I want to differentiate that between the actual rig or the component classes. So if you look at the rig class, that is actually not a meta class or meta node. What exactly is this? Well, the rig is essentially a set of utilities that sit on top, and it's mostly related to tooling and build system. This is the same for components. When this gets returned, it's not returning this meta node. It's actually returning the actual class of the build system. So this is where all your logic sits. If you have a look at the help docs, you'll start to see it's got the actual setup code, and everything that you would use in your custom component. This is important because you don't have access to, say, the underlying, let's say, I want to get access to the IK spline squash curve because that's custom metadata that I've added into the component during the build. Well, I can't access this in this way from outside. Right? It doesn't exist, and that's because it's a Python class, not the actual. It doesn't refer to the node. What I have to do is get into access to the meta, and now I have access to this particular attribute. And if I wanted to, I can get access to the node. Now I have access to the animation curve relating to the spline. And if I then go and say, I was going to say this is the curve. And if I now go say exactly.select curve, oops. There it is, right? This is custom metadata that I've actually added into the component during the build. And this gets interesting because this exact same node is used in the guide. This allows you to customize the squash and stretch, or the actual squash of the curve when it's in the actual spline. Now, we can go a lot further in this and start looking at the actual underlying API of Zappy, which we will do. We're going to get into Hive a little bit more into custom components, and so on. But I wanted to point this kind of stuff out because everything you're going to do from here on out is related to Hive is going to be related to this backend. So understanding the basics of this is pretty important. Now, let's do one thing before we go anywhere. Before we end the video, let's do one thing. One of the most important things you'll end up having to do in an animation tool is access your animation controls. So let's do that really quickly. I'm just going to rewrite some of this. What I'm going to do is go create a for loop that goes spine.rigLayer. Right? Now I'll point that out in a moment. I'm just going to go iterate controls. And I'm just going to go and say print ID and print PI, the node as well. So now if we run that, you'll start to see something. You have got the actual ID from the spine, and you have the actual node graph, right? Obviously, this part here is the node that we actually renamed. But you can see names don't matter anymore because we're accessing the actual metadata. Now, rigLayer class that we returned here is the actual node of rigLayer. So this is not this guy, but it's what it's actually connected to. I don't think it's going to return because I need to have a limit. And if we have a quick look for that, it's this guy here. That's what rigLayer returns. And the reason why it returns the meta node and not like a encapsulated class like an abstraction is because it's not part of the actual build system in that regard. It doesn't contain build system logic. It only contains the necessary needs to attach things to the layer or query things from the layer. Now, I do suggest that you jump through the code of this and you can find the actual underlying metadata code inside of ZooMaya. During the edit of this video, I found that I didn't capture my screen correctly for the next part of the video, which was going to be deep diving into the actual code of the MetaSystem. So instead of doing it here, because you're not going to be able to see it properly, I'll go be doing that in another video. So I'll see you then.